Okay, but now what we can get is problems where they are intersecting. So what we can sometimes get is like if the modulus and argument ones are intersecting and we have to find what z is. So like this one over here. So it says find the complex number z which satisfies both the modulus of z minus 4 minus I equals 5 and the argument of z minus 1 minus 3i is pi by 4. So how would we go about doing this? Well, like we said earlier, we need it in the form like this, z minus z1. So z minus z1 is equal to z minus 4 minus I. So what we're actually doing is z minus 4 plus I equals 5, right? So our z1 is 4 plus I. And we know from earlier this is just a circle centered 4, 1. So center is 4, 1 and the radius is 5. So we can just draw a set of axes. Center 4, 1, so let's say that's 4. This is I, this is the real axis, imaginary axis. So we'll center at 4, 1. And it goes like this, let's say. So this is our loci for the modulus of z minus 4i equals 5. Now, we have the argument of z minus 1 minus 3i. Now again, the argument is z minus z1. So z minus z1 is z minus 1 minus 3i. So what we're going to get is the argument of z minus z1, which will be 1 plus 3i, is equal to pi by 4. Now we know this is going to be a half line from the point, so half line from 1, 3. So let's say this is 1, let's say this is 3, so 1, 3 is going to be over here. Oh, but it's going to be a half line, so we'll have the open dot there. And the argument is pi by 4, which is 45 degrees. Well, if 90 degrees is going to be like that, 45 is going to be going up like that. So we'll get something like this. Remember, this is just a sketch, so it doesn't have to be exact. If we draw this dotted here, we can say that that is pi by 4. So now, find the complex number z which satisfies both this and this. Well, where it satisfies both is this point of intersection over here. So what we have to do is solve for the point of intersection. Right, so we know the circle centered 4, 1 has radius 5, so the equation of the circle is x minus 4 squared plus y minus 1 squared is equal to r squared, which is 25. Now the straight line is going to be like simultaneous equations, so we find the equation of the straight line, substitute it into here, find our x and y values, and then find the complex number with those x and y values. Right, now we have got one point over here which is 1, 3, and we're told that this angle is pi by 4. So we're imagining like this is the axis, that's where the line's coming from, we have an angle of pi by 4. Now hopefully you may be thinking that, oh, if it's an angle of pi by 4, the gradient is 1. Why is this? Well, if we draw this triangle, so like this triangle created over here, so let's say it's like that, so this is our y value, this is our x, this is right angle, this is pi by 4. Well, what we can say is y over x is going to be tan of pi by 4, which is 1. And y over x, well, this length, y, is just going to be like the change in the distance from here to here, and the x is the change in distance from here to here. So our distance is this, so this is our change in y over change in x, which is the gradient, which is 1. So we have a gradient of 1. So we can, and we have the point it passes through 1, 3, so what we can say is the line is y minus y1, so y minus 3 is equal to m, which is 1, x minus x1, which is x minus 1. So we get y is equal to x plus 2. Now this is just simultaneous equations. So x minus 4 squared plus y is x plus 2, so we'll get x plus 2 minus 1, which is x plus 1, so x plus 1 squared equals 25. Expand out, x squared minus 8x. But wait, we're just looking for one intersection. But if you see here, if we extend this line, this will pass through another point over here. But I guess with this axis, or with this line, this angle is not positive pi by 4, that's more likely to be negative pi by 4. So we're just using this, and we can see that this coordinate clearly has a positive x and y coordinate. So we know that our coordinate will not be minus 1, 1. So our coordinate is 4, 6. But that's not what we have to find. We have to find the complex number z which satisfies this. Well, we know that z is x plus iy. X is 4, y 6. So z is 4 plus 6i. So this is our answer. So z is 4 plus 6i, and this is the complex number which satisfies both of these loci. Alright, now these exam questions, these crazy looking things. But I promise you they look crazy, but they're easy. They are much easier than they look. So let's just crack on with it. By the way, I've got a cold, so if my voice is sounding a bit weird or might be sounding bunged up, that's because my nose is blocked. I've got a cold. Anyway, right, well, from pure year 1, chapter 3, we literally did that in school like 2 weeks ago. Set notation shouldn't intimidate you now, if you know it. All this is saying, squiggly brackets are just a fancy way of saying it. Z is a complex number, Z is a complex number, blah blah blah. We do not care about that. We care about this. We care about that the modulus of Z minus 4i is less than or equal to 3, and we care about that the argument of Z plus 3 minus 4i is between minus pi by 2, or bigger than minus pi by 2, and less than or equal to pi by 4. That's what we care about. Let's just break it down. Let's start with the first one over here. So ignore this for now. We can see we've got a modulus and we've got a number which is like in the form of r, which is just like a constant. So we know this is in the form the modulus of z minus z1 is equal to r. And we know this is a circle with radius r centered z1. So if you rewrite this in the form, what we get is the modulus of z minus, I guess you could put 0 plus 4i because that's showing what z1 is, so let's just do that. So 0 plus 4i. Now for now let's just put equal 3 because that's what we know so far. So this is going to be a circle centered 0, 4 with radius 3. So let's just graph that. So let's draw axes. So okay, so let's say 0, 4 is over here. So then we can say that if the radius is 3, this will be like 0, 1, so that's where the circle will go up to. So we want something like that. This circle over here, let's just center that properly on 0, 4. Okay, something like this. We'll just, this is 3, we know that that's 3. So this up here, this point over here will be 0, 7 because we're adding on the 3. And this will be 0, 1. So, now this inequality, so this is the region and we have to shade on the Argand diagram. So this first region over here, we know it's a circle, but we want the points that are going to be less than or equal to 3. Well, the radius is 3, so anything less than 3 will be contained within the circle. Anything greater than 3 will go out of the circle. So everything less than or equal to 3 will just be the whole circle shaded in because it's everything in the circle satisfies that. So we know for now that basically a whole circle is going to be shaded. Now let's look at the next bit. Z is a complex number, and we've got the argument, so we know it's going to be in the form the argument of z minus z1, I guess, is equal to r, and we can have like two values of r. So first minus pi by 2 and then pi by 4. So what we get if we rewrite this, so we'll have minus pi by 2 argument of, right, z minus z1, that's going to be z minus 3 plus 4i. So we're going to have this. So basically what this is saying, we know it's going to be a half line. Now it's going to be between two values. So we're going to have a half line and it's going to be a dotted line because this is not including. Right, so we are greater than minus pi by 2, but it's not including minus pi by 2 because we've got that, so it's going to be a dotted line. So we're going to have to draw minus pi by 2 down like that, at 90 degrees downwards. but then this bit over here we're including, we are less than pi by 4. Well, this would be pi by 2, so pi by 4 would be something like that. So pi by 4 is 45 degrees, so it'll be something like that. So we want to have this drawn, and it's going to be everything shaded here because that's what's between minus pi by 2 and pi by 4. Okay, so if we draw that, so it's centered minus 3, 4. Right, well, minus 3, 4. Okay, right, because the radius is 3, well, this is going to go to minus 3. And we're not moving in the y direction, so actually minus 3, 4 lies on this circle over here. That's minus 3, 4. So let's just label that now. So let's just put down minus 3 there. And because it's a half line, remember it's going to be an open dot like that. Okay, so like we said, the dotted line is minus pi by 2. Dotted line minus pi by 2 down. It's going to be something like this. Move this over here so it passes through the minus 3. Looks like it's probably vertically down. And then we're going to have a solid line at an angle of pi by 4. Now pi by 2 is up here, so pi by 4 is going to go something like that. So if we draw it going through like there, like that. So because our argument, our angle is between these two, well, everything between these two is all of this space over here, like we said earlier. So now what we want is the space that's common to both of them, because we've got this and, that means and. So we want this space and this space. Well, we said the first space was the whole circle, and now the next space is this. So now this and over here is saying what's common to both of them. Well, that's just all of this bit of the circle over here. So now if we shade that, so if we shade it like this, so all of this shaded bit there is our region, and that's done. That is 6 marks for us right there. Okay, now part B. The complex number W satisfies this. Okay, now straight away, if you notice, this is basically this, except we've got an equal over here instead of an inequality, and we're W instead of Z. But same thing, it's going to be a circle, radius 3, centered 0, 4. Find the maximum value of the argument of W in this interval. Right, curly bracket, square bracket, what's going on? That just means between minus pi, not including, argument W, including less than pi. You should know that from A-level maths. So that's what this over here means. So we have to find the maximum value of the argument of W between minus pi and pi, not including minus pi. Well, if we use our diagram over here, W satisfies this. This is the locus of W minus 4i because it's from this point. But W could lie anywhere on the circle. And we want to find the maximum value of the argument of W. Well, the argument of W, because W is a complex number, it's measured from the origin. So it could be over here. If W was over here, then it's measured like that. So this would be theta, which would be the argument of W. But we want to find the maximum argument of W. So the maximum argument of W would be if like W is like somewhere here, and we've got something like that, where that's the maximum possible angle we could make. That's the maximum argument of W. So it's going to be a tangent to the circle like this, and this is going to be the argument of W. Now we can see that clearly if we have this over here, we have this angle over here, we've got pi by 2 over here, we've got the argument of pi by 2 over here, and then we've got this angle over here, if we call it like alpha. So if the whole thing is theta, we can say that theta is pi over 2 plus alpha. So what we can say is that the maximum argument of W is equal to pi over 2 plus alpha. And I guess we should have some indication of what alpha is. So if we just quickly sketch that again, this angle over here will be alpha. Now, what do you think we notice? We know that the radius of this circle is 3, so this is 3. This is a tangent, so we know that this is a right angle, and we know that this length is 4. So we get a right angle triangle like this. We've got this angle alpha. So if we draw this triangle out, what we've got is this. Got a right angle here. We've got this angle alpha over here. We've got 3 and we've got 4. Right, now what we can say is we've got the opposite and hypotenuse, so alpha is going to be the arcsine of opposite over hypotenuse, so 3/4. So we can now say that the maximum argument of W is pi by 2 plus arcsine of 3/4, and we have to give our answer 2 decimal places in radians, so make sure you're in radians. To 2 decimal places we get 2.42. So this is our answer, 2.42 radians. Well, they've asked for an answer in radians, so I guess we don't have to specify in radians. I guess we can by just putting the radian symbol there. Okay, now hopefully this is 8 marks. I'm sure it will be. Let us see.